Okay. Hey everybody, my name is Brian Locke. Better figure out where I'm looking. So my name is Brian Locke, and today we're going to live stream controlling a Sonoff device and reprogramming it using the Arduino IDE. So first, what does the Sonoff device do? Well, what it's for is controlling a higher current circuit, such as a light or a regular socket, using a small device such as an Arduino or a Raspberry Pi. And basically what it is it's a consumer device, so it's available already pre-assembled, that's powered using an ESP8266. And I've got my first warning light. Let me see what that is. Twitch is dead. Okay, let's see what's wrong with Twitch. Twitch doesn't look dead for me, Nestor. Or Gary. I stopped and started again, so maybe that's what it is. Thank you, whoever set off that light. This system might actually work pretty well. So I have a couple of friends who are watching the stream, and they are going to let me know using this device here when I need to attend to something. So this is basically an ESP8266 hooked up to some NeoPixels, and when they need me to look at something, they're going to send a message to it through Telegram, and it's going to change the lights. So if I can show that to you now. So it's going to be pretty bright. So yeah, that would be... Yeah, you're not going to be able to see that, but yep. So you can send messages to it. So that's a nice little thing. I just need to let the Adafruit Discord guys know that it started, because they'll probably make up the majority of the viewers I have. Let me just send them a link. Is the sound okay? You can hear me alright? Also, if you want to ask questions, work away. The guys will probably be monitoring the chat, and they can let me know if there's anything that I need to answer or whatever. Okay, so back to this. So I suppose it would be worth showing you a Sonoff device rather than me just talking about it. So this is a Sonoff device. They are very cheap. They're about $5, and basically what they are is the equivalent of this. So this is something I made last year. It's a ESP8266, it's a Wemos D1 Mini, and a 5-volt relay. Now, one problem about this setup is that it requires its own power supply, so a separate one. So what this device was for was making a smart plug, so the ESP8266 could turn on and off the relay, which would turn on and off power to these sockets here. So I actually used it for my Christmas lights, but as mentioned, it required its own plug, which obviously couldn't be plugged into this, because when it's off, how would it know to turn back on again? So what's nice about the Sonoff other than the fact that it'll be a much nicer case than this, is that it gets power from the wire that you're intercepting. So it's got, let me just open it up here. So it's got an input terminal here, and this, not only does it control the output using the relay here, it also powers the ESP8266, which is there, if you can see it. Yeah, so it's a cool little board. So it comes with regular software on it, but because it's an ESP8266, we can reflash it with whatever software we want on it. So we can reprogram it the same way as we can control the Wemos D1 Mini or any ESP8266 chip. So yeah, what we're going to do is we're going to look at flashing this, and also kind of what other kind of tricks you can do with it, like as in obviously the relay is available to you, but what other things are, like this LED turns on based on the status of the plug. This button also can be used to turn on and off the device rather than using something on the internet. So yeah, just so I showed you just a regular device with a relay. Another option for controlling mains power is something like this. So this is a remote socket. It comes normally in like a set of 4 or whatever, and there's like 4 numbers on it, and each number corresponds to one of the sockets. So they're a pretty standard frequency in terms of, it's, I can't remember which side of the kit they are, but like these are a really cheap set of kit. I think they're like $1 or something, and one of them, I think it is this one, can communicate directly with this if you have the right address for it. And another nice thing is you can use this one to get the address back, or like learn the address from the remote. This socket, just interestingly enough, I do not know where the remote is, but some kind soul on GitHub uploaded a sketch that had all the addresses for it. So I don't have an example of it working now, but maybe like nearly a year ago I did have one and it worked perfectly. So thanks to whoever that kind stranger was. Let me just grab, what do I need to grab? Sheet. So, one second, actually I can make the camera less bouncy. I forgot to attach the retention springs on my camera mount. No, hopefully it is less bouncy. That's still pretty bouncy. The desk obviously isn't that great. So the black and white is a little bit hard to see, but obviously this is a printout of the Sonoff circuit board, and it's from randomnerdtutorials.com, so thank you to them. So what's pretty nice is that the Sonoff really is meant to be kind of hacked. They haven't tried to make it like something that you can't hack or anything. Like, they've even exposed these pin headers, which are everything you need to program the Sonoff with your own firmware, and even it has one extra one exposed, and we'll take a look at that later to see is there anything fun we can do with that. So yeah, it's really nice that they do that for you. So basically what we want to do here is let's see if I can zoom in a bit better there. Wrong webcam. have two Logitech cameras, and I don't seem to be able to change the one that I want to change. Interesting. 20 HD. Awesome. So we probably can't focus any better than that, unfortunately. Thanks, Logitech. Be less important to not have to focus on the other one, which is my face. I don't think anybody wants to see that. In advanced settings, no, I can only launch for the one in the corner. Okay, that might become a problem. Let me try fix that. I will try plug. What will I try do? I really need to be able to look closer at the board, or for you to be able to look closer at the board. Like at the moment it's, I can move it down a bit if that will help. No, it's even less zoomed. I guess it's not on autofocus mode either. Okay, I have a message. It is question on Twitch chat. Okay, let's address that. I am so unused to Twitch, I don't even know how to see the question that's on the Twitch chat. Where is it? It's not a whisper. I am not seeing the chat, Gary, in the Twitch. Any suggestions on edit panels? Maybe? Nope. Can the Sonoff sense current draw on the switched side? Can it sense current draw on the switched side? So no. So basically, I think the question is, can it detect if current is being drawn, and it can't. All it can do is turn on and off that, and yeah, I'll actually explain how a relay works, and that would kind of let us know kind of how the Sonoff works then as well. So this is a relay module. Thank you, whoever turned off that light. And surely I have a better color marker. So the way a relay works is basically, it's a completely isolated circuit. So you've got your large voltage here, this side, so we'll say this is in Ireland, this would be 220 volts AC, and then on the other side we have logic level, so it was 3.3 volts of an ESP8266. And basically how it works is this device will be, say, open when there's no connection here, so that's the off mode. But then if you set this pin high, like you apply a voltage through here, there is basically a magnetic field that closes the switch. So they are completely separate from each other. So this 3.3 volt device, it has applied the voltage along here, and it doesn't know is there anything plugged into this. It doesn't know anything. All it knows is it's applied the voltage, and it's hoped that this bridge is closed. Now, I wouldn't go into your electronic engineering final year exams or anything and put this down as a relay, but this is a rough idea of how a relay works. So no, there's no sensing whatsoever. They're completely isolated from each other, which is a good thing because you don't want your DC and your AC to cross over. There is some external non-invasive sensors that I've seen that you would like wrap around the wire, that you could use to sense current draw, but a relay doesn't do one. So thank you for the question, whoever that was, and I'm sorry I can't find Twitch chat. I'll promise to learn it. Okay, cool. Right. So yeah, back to the Sonoff. So yeah, what we want to do is basically we want to solder up these headers here, so we're able to program new software onto the ESP8266. And so what I'm going to do is I'm going to solder some female headers onto all of these here, and then I'm going to use I have an external programmer here, which is which you would normally use for a regular ESP826601, which is this kind of a board. So you plug that in there, plug it into your USB, and program away. But obviously, like, these pins correspond, some of these pins obviously correspond to the same ones here, so we're going to wire them up, and then hopefully we will be able to get it working. So let's get to that. Let me grab my soldering iron. Blue light. Okay, you can use twitch.tv/dashboard. That seems to be working. I can stop playing relay Drew the Ogre, are you from the Adafruit Discord? There is someone there with a similar name. Okay, so let me go back to my. Yeah, hi Gary. So yeah, this is my TS100 soldering iron. Pretty nice. It's really small, really small. Its power supply is almost as big as it, which is kind of weird. Yeah, I've had it maybe like a couple of weeks, and it's so far it's been pretty nice. I just need to get the clover cable for it. So what's one thing that's really nice about the TS100 is it boots up super fast, or heats up super fast. So I press just one button. Keep my hand away from it. So as you can see there, I went from cold to pretty hot pretty quickly. Move that out of your way so there's no steam or whatever going up to you. So now we need to get some headers. I've got some spare headers. So these are just standard female headers that I got from an ESP8266, or sorry, a Wemos D1 Mini. So that comes with 3 different headers, and I normally use the male headers, so I have a lot of these ones spare. So I only need to use 5 of them, so I need to cut it. So let me get my pliers. Back here. You can see the mess accumulating on my desk. Well, it's not actually my desk, it's my dad's office. I do not have the internet to stream at home. So this stream is sponsored by Graphic Tiles. If anybody needs tiles, let me know. Oh, it'd help if I showed you what I was doing. So I don't know if this is the best way of doing it, but let's try it this way. So I'm just cutting fairly far away after the 5th one using a standard standard snips. Yep, so that worked, but I also don't know if you could hear it. It flew across the room too. So yeah, well, if it works, it works. So let's see, do they slot in okay? And they do, they slot in perfectly. So now we're just gonna solder that. If anybody knows me at all, my favorite soldering tool is Blue Tack. So I'm gonna get some of that now. One of the hardest things about doing a stream here, so it's late enough on a Saturday evening in Ireland, so it's closed, the shop, so there's no issues with people or anything, but moving all the stuff that you might need for a stream, like, it's fine, say the cameras and the mic and all that stuff is kind of known stuff that you'll need, but yeah, it's more the electronic stuff that I'm worried about. Like, I brought a ton of stuff, but we'll see how it goes. I'm sure I'll end up missing something. Okay, let's just check for anything. Yes, hi Drew. And oh, hey, it's Learn Electronics. I actually don't know your name. I'm pretty sure it's Paul. So hi Paul. He's asked a question on the YouTube channel. How much thermal mass does the little iron have? It is pretty good. I've got 2 heads with it at the moment. This is one of them. I'm looking at YouTube rather than OBS, and this wasn't the best at heating up. I thought the thermal mass on this one was a little small. The one I have on it now is more of a kind of this one, but chopped. It's kind of hard to see with the focus on this camera, which is bad. And that one works better. I am going to order more of a chisel style tip though, because yeah, I'd like it to be a little bit better. But yeah, it heats up so fast, which is pretty nice. I haven't really used it for too much. I kind of sillily enough, I did a project with a lot of soldering recently enough, an LED matrix. I hope to make it into a video soon, similar to what Great Scott did, and so there was a lot of soldering in that, and for some reason I decided to buy a new soldering iron after I did all that work with a crappy soldering iron, so that wasn't very smart. Okay, so hopefully you can see that. I'm just holding the pin headers in here with blue tack so they won't move now. So now, my first time soldering on live video. So let's get ourselves positioned for this. Hopefully I won't be in the camera's way or the light's way for soldering. So that is okay. I'll just put a bit on the tip. Okay, let me just check the comments again. Hopefully that answered your question, Paul. I used that soldering iron in like 3 hours. It's pretty weird to have a soldering iron that fits in a component drawer. So yeah, when I'm not using it, I put it in my component drawers and just leave the power supply out on the desk. Because it's so fast to heat up as well, like, you know, there's no kind of time lost by putting it away somewhere. Right. Okay, first one done, but I probably have done these the wrong way around. Let's see, it's blurry, but you can see okay. At least I'm pointing the right direction. Okay, second one done. Third one done. Or third one, if I was to say it in my actual accent. Might be a bit quiet now. I did a video before where I was soldering, and I find it really hard to concentrate on talking loudly and soldering at the one time. Ugh, I made a mess of that last one, but we can tidy it up. Okay, so they look okay. Hopefully they are. One really nice thing about the TS100 is it goes into a power saving mode if it has an accelerometer built into it, which is kind of weird for a soldering iron to have something like an accelerometer in it. But it does, so you can configure it that, like, if you put it down for like 20 seconds or more, that it'll go into this like cool down mode, which will like reduce the temperature of the soldering iron to save power. And then also you can set it that it can turn off after it's been in that cool down mode for a certain amount of time. So as you can see there, we're in, and blue tack all off now. So that was a relatively painless way of holding headers in place while you're soldering. Cool. Right, so now I do have a slight problem that I need to plug this into my PC and connect it to this, but I don't think I have a USB extension cable with me. So let me just try move my my USB hub as close as possible, but I think I might need to, actually I can just move the camera actually. That might help a little bit. I also need to find out the pinout of this to make sure I connect it up to the right thing. So let me probably not a great idea to be creating OBS scenes while I'm streaming, but let's go for it. Video capture device, existing Logitech wide. Video capture device, no, screen capture. Display capture. Yes. Okay. Well, let's fill up that little. I'm using one of the monitors that was already here, so it's pretty small. Okay. Hopefully you can see that okay. You're probably looking at me at the moment. Yeah, guys, Gary, Nestor, and Paddy, if you could set the NeoPixel if there is a problem, that would be great. So you should be able to see my screen now. So I'm basically looking for the pinout of a ESP826601, which is normally what this device programs. So if we get that, we can figure out what we need to do here. So view image. Okay. So we need to connect VCC, obviously. So when you're connecting this board, you connect this back on top of itself. So the top left one here is VCC. So let's draw that out. So we've got a little square here. You can see my lovely drawing. Right, so the top one is VCC. The bottom right one is ground. And we need RXD and TXT. So this is RX and this is TX. So we need to connect VCC to 3.3 volts. You can't see me drawing on this. We need to connect RX, these two together, TX together, and ground together, obviously enough. So before we actually even start, let's do that. Okay, I can probably switch back scene now. so we will use relatively long ones to get as far as we can. So I'm just going to take 4 here. I have a black, a white, a grey and a red. They're close enough to the kind of colours that you want to get, and they're actually in a pretty nice order too. So I'm going to plug them straight in. So as I mentioned before, the last pin that was available is GPIO 14, so we actually don't need that for programming. So that should be us covered on that side. It's a real pity about how focused it is. Might take 2 minutes to fix that later. Okay, so now we just need to connect it into this device, and we've got this super nice diagram here. So VCC, which is my red cable, is up there. What else do we have? RX is the second one, so that's my grey cable, and that's down there. And then we have white goes into the top and black into the bottom here. So hopefully that is everything we need to program it. So obviously enough, when we're programming it, we do not want to have this powered by mains. We don't really want mains anywhere near it at the moment. Yeah, so like it will get powered by this device here, which if you are doing any work with an ESP01, I really recommend getting one of these. It's pretty handy. Weirdly enough though, you do need to install a switch to trigger, I think it's GPIO pin 0 to 0 or to low to get it into boot mode. This button here, which comes with the Sonoff, is attached to GPIO pin 0, so hopefully we can use that to trigger boot mode as we're powering it up. Yeah, so that will let us flash the device. So now let's see how we get on with my USB hub. I can get it somewhat close, but not high enough. Do I have anything to hold it in place? I do have something I can use to hold it in place. To hold it in place. Blu-Tack. I don't know, is Blu-Tack going to be strong enough, but we'll give it a go. Look at this, a maker's dream. Is there anything Blu-Tack can't do? You can see my lovely dirty computer too. It is kind of dark in here. That is because there is those kind of office lights that flicker. That is completely apparent on screen when I was doing a little test run. So even though these are pretty long cables, they don't leave me a lot of room to play around with. Oh no. I need to stick it the other way around. Oh, that even gives me a little bit more. This is a powered USB hub that I got off Amazon. Better not plug that too much in there. Amazon Basics. It's pretty nice and works really well, but this is my second one. I had to get a replacement last week. And Amazon replaced it, like, no questions asked or anything, but I only got the first one in like May, so that's a little worrying, but We'll see how we get on. So we got a flashing light there that is at least somewhat promising. I presume what we're seeing at the moment is standard behavior for the software that comes on the Sonoff before we do anything to it. So it's probably waiting for you to connect to it with an app or something to put in Wi-Fi credentials, but we don't really care. So, excuse me. What I'm going to try to do is I'm going to lift out the power. I am going to hold down GPIO pin 0, or the button. I'm going to struggle to plug power back in. Oh, come back. So even though this is a device for mains, because I don't have any mains plugged into it, there's currently no risk of electrocution. Now it's not flashing green, so hopefully that means it's in bootloader mode. Hope you can see it's not flashing green actually. Okay, let's boot up the Arduino ID. Let me find it first before I switch you over to the desktop. Oh no. Okay. Another thing actually I need to do is figure out, I probably are all going to see my password now. That's fine. I need to figure out what pin the different things are on. So let's do that together. Okay, hopefully you can now see my desktop. Actually, before I switch back to my desktop, let's take a look at the chats that I'm neglecting. We're doing it live. There's a USB hub in my monitor. There is a USB hub in my monitor that's not plugged in, but well spotted. How cold does it get when it detects idle? It has turned off now, actually, which is pretty nice. That is also settable. I think it goes down to 120. I'm confused about the board, specifically the huge solder traces. The huge solder traces are for connecting one end of mains to the other, so that's why it needs to be so big. It says the board is capable of carrying 10 amps, so 10 amps at 220 volts is quite a lot of power, obviously enough. And actually a bit later we can talk about like what kind of things that this can power, or how can you figure that out. And yeah, so that's why they've such big solder traces. It's because that is actually carrying mains power along those solder traces. So when this is plugged into mains, that is a dangerous device. So yeah, you definitely don't want to be messing around with that. Any questions on YouTube? No. Awesome. Okay, so let's switch to the desktop. Okay, so we need to find out. Oh, my Sonoff, or my virus protection is out of date, and Fuberto is playing something on Steam. Let me just exit Steam. Okay, Sonoff, pinout. There is a pretty good tutorial on GitHub, or information on GitHub about the different pin locations. Yes. Yeah, So I don't know, hopefully you can see that okay. So you can see here that oh, that's not good. Bluetech, you failed me. Hopefully I didn't short out anything by connecting to the metal grill on my computer. Let's not make that mistake again though. So disappointed in Bluetech. See that tape not working. And Drew, to answer your question, I don't think I have a cable for that monitor's USB hub either, so good spot, but I don't think I can use it, unfortunately. Hopefully that will work out for me. I'm going to cover the metal part of my computer now. And I will also put a little bit more Bluetech on this guy, because you can never have enough Bluetech. Hopefully that works and it didn't short out anything. I have a spare Sonoff board if it did. We'll have to resolder again. Okay, so yeah, let's do this really simple first. Let's try flash the GPIO 13, which should be the LED. So that'll just prove out that we're working. Okay, so we want to select a generic ESP8266. And then for flash mode, I think it's DIO. Flash size, it's probably the smaller size. The reset is probably CK. We'll find out. So file, examples, ESP8266, and we'll go for blink. And now we will const LED, we're saying it's pin 13. Let's make it, I don't know, status LED on 13. Let's replace all of these. This one, the built-in LED on an ESP8266 is active low, so when you turn it on, when you set the pin high, it actually turns off, and vice versa. So I don't expect that to be the case with this, but I don't really want to save this anywhere. So let me just upload it. Oh, I have not set my status LED. Does not know a type. It's not const I want to do. It's define, and it's probably all lowercase. It's probably all uppercase. Oh, dyslexia, don't fail me now. Oh. Ah, yes. Sorry about that, that's pretty basic. So let's just compile for no reason. It's probably going to compile. This might be a good time while I'm uploading it to put it the right way around. Move this out into the table a bit more. Cool. So that compiled fine, obviously enough. So let me just try upload it. Let's see. Yes, thank you, Drew. It is hash to fine. I do have some more stronger tape with me, but I'm a bit worried about leaving marks on a desk that isn't mine. Yeah, why Drew has said why the beefy solder, why the thick solder basically on the board. If you didn't see it, it's pretty deep under there. Instead of just a beefy solder truss. I guess they just didn't have room. I think EEV blog, Dave Jones did a thing before about how these are a load of crap, adding all this extra solder or whatever, but I can't really remember. The electronic side of things, like power or whatever, isn't really my strong point, but I do what I can. And the 120, that was that saying country units are freedom thermal measurements. I actually don't know. So basically he's asking, is the soldering iron in degrees or Fahrenheit? I think you can change it, but I think it's based on degrees Celsius. So I don't see a flashing LED, but I also see an upload fail. So let me try press the button when I'm uploading it, maybe. Failed to open COM4. It's because there is no COM4. I don't like the way that there's only a COM1 though. I do have a spare Sonoff, but I don't know if I have a spare programmer. Powered on the Sonoff anyways, so it's back to flashing green again, but that is not the sketch here. So awesome. What are you looking at? The desk. Yeah, I'll keep you on the desk while I try to figure out. So it sees my device and sees it on COM9, but says it's unavailable. Device cannot start. Let me try. Let me try plugging it in without anything in it. Awesome. Needs troubleshooting. It sure does. I'm going to try to plug it directly into the computer. I've got a new COM port, but it's still saying that it can't start the device. currently trying to reinstall the driver for it. This was working for me quite recently. Still has a driver problem. Normally what I would do in this scenario is just restart my computer, but that may be a problem for the stream. I need to do something to get it working. It's weird, so it sees that there's a device plugged in, it's using the correct driver, the CH3040, and it's got a COM port, but it doesn't look like it's working, and the Arduino IDE also doesn't see it. So I think I'm going to need to restart and get this working, because I have no other way of reprogramming this, I don't think. So yeah, sorry about this, bear with me, and I'll be back in 5 minutes.